Can you crack this circuit using Kirchhoff's laws? Wait, this looks tricky. It's complex and we should know the trick to avoid taking a loop with two batteries. But guess what? It's actually easy. Let's use Kirchhoff's laws and loop sign conventions to cark this question. Before proceeding further, let's quickly recap Kirchhoff's laws and loop sign convention. This first law is in accordance with conservation of charge, which means that there is no loss of current around a junction. Kirchhoff's second law, that the algebraic sum of voltages produced and the voltage dropped in a closed loop, a closed path, of an electric circuit is always zero. In Kirchhoff's second law, the total voltage or EMF around the junction is equal to sum of products of current and resistance of all the loops. This law is in accordance with law of conservation of energy, which means that there is no loss of energy around the junction. Now let us understand how to form a loop and give sign to a current. This is done using Kirchhoff's loop sign conventions. So the direction of current is taken as positive if the direction of the current loop in circuit is in same direction to the direction of the loop we draw. And the direction of current is taken as negative if the direction of the current loop in circuit is in opposite direction to the direction of the loop we draw. You can see the loop draw here. This is an hypothetical loop ABCD. The direction of current in this loop is clockwise moving from AB to BC to CD, and then from in opposite direction from A to D, which is anti-clockwise. Thus, the current I1 is flowing through resistance 1, current I2 is flowing through resistance 2, current I3 is flowing through resistance 3, and current I4 is flowing through resistance 4, but in opposite direction. Now we will draw a loop in a clockwise direction. Let's match the direction of current in the circuit and the loop we have drawn. The current I1 will be positive as direction of current flowing in circuit through resistance 1, and loop drawn is in same direction. Current I2 is also positive as direction of current flowing in circuit through resistance 2, and loop drawn is in same direction. Current I3 is positive as direction of current flowing in circuit through resistance 3, and loop drawn is in same direction. And current I4 is negative as direction of current flowing in circuit through resistance 4, and loop drawn is in opposite direction. Now we have done a quick recap of Kirchhoff's laws and loop sign convention. Over to my friend. She will crack the circuit in an easy way, so over to her now.
I'll go for the similar question. Draw the direction of current, and the second step is to draw the loop. Then the third step is to write the equation, and the fourth step is to solve and get the answer. So again we are going to follow the 4 steps. Now our first step, using the 2 Kirchhoff's law, I am going to solve the circuit. Now you can see here that we have one battery here and the other is here, and from EF there is no battery, nothing. So in that case, whenever you have this kind of question, you have to include this resistance. So one of the loop you are going to take the full loop. That means the bigger loop is going to start from here, it is going to include this and it is going to end. Then the second loop will be the smaller loop that you are going to take, and the smaller loop will be this one. It is going to start from here and end here, right? You can take a smaller loop this also, but this will create a confusion which one you are going to take. So avoid taking the loops which has both the battery. Remember one thing, if you have to find the potential difference or the current or anything related to the resistance which doesn't have a battery, then it is a hint that you have to take one big full loop which includes the whole circuit. And given a choice to take the small circuits, always take the circuit which has one battery. Avoid taking the 2 batteries, because otherwise it is going to create a lot of confusion and it will become more complex in that. So this is how you have to segregate. Now you know that you have created the loop. Now we can write the equations in this case. This was my first loop and the other is my smaller second loop. So let's start now. Okay, now I'm going to write the 2 equations. Now my first equation will be the bigger circuit, that is ACEFDB. This is ACEFDB. So in this case, you can see here that the loop current is passing through here and we are going to take the direction of the current. So let the current I1 is passing through A, then the current I1 is passing through here, and the current one will go from here. Remember that you're not going to pass the current one here, no, because from here the current 2 is starting. So practically I'm just removing this to avoid any confusion. You're not going to make the current one pass from here. The current one is passing through the full loop because we have taken the full loop. Don't make that error. And current I2 is passing from here. So practically from CE we have I1 and I2 passing. So that means from your 5 ohm you have I1 plus I2 passing, and from DF also you have I1 plus I2 passing. Now at the D junction, again it is going to segregate. So from here you have the current I2, and here the current I1 will pass through BD. So the current I1 is going to go here and the current I2 is going to reach this 2 ohm. So now I'm going to write the equations. On writing the equations for the full loop A, C, E, F, D, B. So this I1 is passing here. We don't have any resistance. This loop is going here. This is my direction of the loop. And I will see here that this is my direction of the loop and this is the direction of the current. So that means it will be positive. So in this case, I1 plus I2 into 5, right? And then this is going here and it is reaching the D, and from D I2 is passing through this ohm. So again the my direction of the current is towards the left, and the current is also passing to the left. They are in same direction. So in this case the current is passing here. I have to consider the full loop. So if I consider the ending here, then the current I1 is passing through this B point and it is passing through this resistance R1. So in this case it will be I1 into 1, that will be equals to 1.5 volt. So if I just open the bracket, that is 5I1 plus 5I2 plus I1 is equal to 1.5. So on solving this, I'm going to get 6I1 plus 5I is equals to 1.5. This is my from the bigger circuit. Now I'm going to take a small circuit, that is CEFD. That is CEFD. In this case, the current I1 and I2 is passing through the 5 ohm, and this I2 current is passing through the 2 ohm, and you can see that the direction of the current are same, and that will be equals to 2 volt. So in this case this is 5I1 plus equals to, these are the two equations that you need to solve. So I will write down both the equations. The first equation is 6I1 plus 5I2, that is equals to 1.5, and the second equation is 5I1 plus 7I2, that is equals to 2. On solving these two equations, you should get the value of I1 as 1 upon 34 ampere, and you should get I2 as equal to 9 upon 34 ampere. Now what was the question? That we need to find the potential across the 5 ohm. So from here the current I1 and I2 was passing, so the potential across the 5 ohm will be equals to I1 plus I2 into the resistance. That means 1 upon 34 plus 9 upon 34, and the resistance is given as 5 ohm. On solving this, you should get the answer 25 by 17 volt.
Hope you understood the concept easily. For more helpful videos on Kirchhoff's law, don't forget to click the link below. Also, keep watching Trans E, learning for more easy-to-follow videos on Kirchhoff's law and other concepts. In our upcoming circuit videos, we will show you how to crack the circuits shown using Kirchhoff's laws and sine loop conventions. So stay tuned with Trans E Learning. Thank you.